Welcome to this explainer. We're going to do something a little bit different today. We are diving into a universally shared sky mystery, but we're actually going to shift our focus entirely away from astronomy and space. Instead, we're going to dive straight into the fascinating, kind of quirky inner workings of your own mind. Because we've all looked up at the night sky and felt that sense of wonder, right? But sometimes, what we're marveling at isn't actually happening up in the stars at all.
So, let's get right into it by asking a question that you have almost certainly thought to yourself while standing outside just after sunset. Why does the moon look huge tonight? You step outside, you look toward the horizon, and there it is. It's this giant glowing orb that just seems completely out of proportion to literally everything else. You might even nudge a friend and say, "Whoa, look at the moon, it is enormous." It feels closer, it feels heavier, it just absolutely commands your attention.
And this brilliant contrast really perfectly illustrates the two very different scenarios we experience when looking at the exact same object. On one hand, you have the moon rising right at the horizon, and in this scenario, it's sitting next to all these familiar earthly things, right? It's dwarfing trees, it's rising behind city buildings, or it's resting on top of distant mountains. But then, you fast forward just a couple of hours, you look straight up, and the moon is floating high overhead. There are no buildings, no trees, no mountains. It's just this lonely, bright little coin surrounded by an ocean of empty, dark sky. And suddenly, it looks remarkably smaller.
Now here's where it gets wild, because we have to completely toss out our immediate physical assumptions. When you see that massive horizon moon, your gut instinct tells you that something physical must have changed. But it hasn't. The moon didn't get smaller, it didn't get closer. The actual physical size of the moon hasn't changed by a single millimeter, and its distance from Earth hasn't dramatically shifted to pull it closer to you. The physical reality of that giant rock floating out in space is exactly the same during a beautiful sunset as it is at midnight.
But hey, you definitely don't have to just take my word for this. You can actually prove it to yourself with a super simple test. The next time you see that giant-looking moon on the horizon, just extend your arm all the way out, straight in front of you, and use your thumb to cover it. Pay attention to exactly how much of your thumb it takes to block out the moon. Then, just wait a few hours until the moon is high overhead, looking all tiny, and do the exact same thing. What you're going to find is honestly pretty astonishing. Your thumb will cover roughly the exact same amount of the moon in both positions. The physical space the moon is taking up in your field of view, it's absolutely identical. And that brings us to the actual concrete term for this whole puzzle, the moon illusion. By doing that thumb test, you've just proven that your eyes are literally collecting the exact same amount of light, and the physical image being projected onto your retina is the exact same size in both scenarios. So if the change in size isn't happening up in the sky, and it isn't happening in the mechanics of your eyes, well, it's happening because your brain is actively altering the experience. It's changing how it interprets the data it's receiving. Section 1. The Science of Relative Size. Okay, to really grasp how the moon illusion works, we have to look at how your visual system is constantly, and I mean completely automatically comparing objects to make sense of the world. Your brain is basically a non-stop comparative machine. It doesn't just look at objects in isolation, it evaluates them based on their neighbors. Think about it like this. A person standing next to a tiny children's bicycle looks pretty big, right? But put that exact same person next to a massive industrial dump truck, and suddenly they look tiny. The person didn't shrink. Your brain just used different reference points. Well, near the horizon, your brain has an entire landscape underneath the moon to use as a reference. It sees the trees, sees the buildings, knows roughly how big those things are, and basically says, wow, compared to that, the moon must be absolutely huge. On top of that, your brain naturally interprets the horizon sky as stretching far, far off into the distance, whereas the sky directly overhead feels more like a flat ceiling just above you. So because your brain thinks the horizon moon is much farther away, but it's still casting the exact same sized image on your eye, it mathematically compensates by making you perceive it as enormous.
Section 2. Why your brain gets fooled. So, that brings us to the real motive behind all this visual gymnastics. Why exactly does our brain do this in the first place? And why is it so incredibly hard to turn the illusion off, even when we know it's just a trick? It creates this honestly hilarious cognitive dissonance for us. You can know the absolute scientific truth. You can literally be an astrophysicist. Heck, even brilliant astronauts who have physically traveled to the moon experience this illusion when they stand on Earth. Knowing the moon isn't actually getting bigger doesn't magically break the spell. Your logical thinking brain says, hey, the moon is the exact same size, but your visual processing center just totally overrides it and projects a massive horizon moon straight into your consciousness anyway. It is completely automatic.
But you really shouldn't feel bad about getting tricked here, because your brain isn't making a stupid mistake. It's actually making a remarkably stubborn prediction based on millions of years of evolutionary visual shortcuts. For our ancient ancestors, surviving in the wild meant having to very quickly judge distance and scale. As a general rule in the natural world, if something looks larger, it's closer to you. If it looks smaller, it's farther away. These shortcuts are incredibly useful. They literally keep us alive on a daily basis, like when you're instantly judging the speed of a car coming towards you. But when you take those earthly, terrestrial rules and try to apply them to a massive, distant celestial body sitting right above a familiar landscape, well, that ancient programming just gets its wires crossed, and it results in this bizarre visual glitch.
I absolutely love this quote. Your eyes collect the light, your brain creates the experience, because it just perfectly captures the essence of this illusion. It completely separates the mechanics of our biology from the magic of our consciousness. Your eyes are basically just biological cameras, right? They are dutifully collecting bouncing photons of light and sending that raw data backward. But the experience of seeing, the awe, the sense of scale, the meaning, that is a story that is completely generated, edited, and produced by your brain, taking that raw data and applying its ancient programming to create something entirely unique.
So the next time you step outside and look up at a giant orange sphere resting heavy on the horizon, remember this. Take a second to really look at it and appreciate what's actually happening. You aren't just observing the universe out there in the dark, you are actively experiencing the beautifully complex, slightly flawed, and entirely fascinating inner workings of your own mind. And honestly, it leaves you with a pretty wild thought. If our brains can so convincingly alter the size of the moon right before our very eyes, what else in our daily reality is just an illusion created by our own expectations?